Alright, so it's been a while since I've streamed. I was busy with some other stuff, but I'm back now. Um, while I was while I was away, I didn't do much really. I I pulled out this calc move. I pulled out this calc move function um, out of the models file. So it was associated with the cell um, data structure. I forget the terminology, but yeah, it used to look like calc move takes a list of cells and it returns a new list of cells. Okay, so yeah, I've taken that out. I've pulled it out into its own function, into a different function, into a bigger function. I'll explain that in a bit. But in the reference source, what happens is that so calc move takes a cell, a list of cells. Sorry, it takes a cell and it returns a cell. That's what it does. It moves this individual cell and all the other cells associated with the game server. So in JavaScript, what you can do is you can have like a reference to something. The problem with immutability is that you have to everything explicitly. So I can't just have a cell associated. I can't just pop a bunch of cells inside of a cell. Like it would be inefficient. So I couldn't do something like see other cells. I'm likely doing a bit of premature optimization here, but if I update this see other cells, nothing will happen to the other cells on the game server. This is a completely different list of cells. It's kind of confusing, but yeah, that's my reasoning behind pulling out the calc move function. It doesn't for our Haskell. Like I don't think that's how you're supposed to do it. So it takes a cell, a list of cells. So these are the other cells on the server, and then it just returns a modified list of those cells. And that's essentially what it's supposed to do. The problem with this is inefficient. So it takes a list of cells and then it produces a whole nother new list of cells. And if you're doing this for every single cell and you're doing it so if there's an n cells, you're doing it n squared times. Like not even worst case scenario, that is the only case. You're doing it n squared times. You have to go through every single cell. So you're creating, so let's say you have 5 cells, you're creating 25 lists of 5 cells to just calculate where this thing is going. What they're doing is they're just modifying an array in place, and because JavaScript has mutable arrays, you can just in place, and all the reference pointing to that is automatically updated. In Haskell, I asked around on the Haskell IRC channel on Freenode, and they suggested that I just use I had 2 options. So the first option is to just continue using lists, and I'm not comfortable with that because it's kind of confusing. It's slow, it's memory inefficient, it's all in all just bad. It's a bad idea. If I was dealing with a few, it wouldn't be a big deal, but the majority of the work, it's the server's job, its main function is to move cells around. That's it. So like if you're doing that inefficiently, then there's no point in continuing. So yeah, the other option that they offered the folks on the channel is that I could use arrays in Haskell. So if I go to Haskell array, there's a wiki article about it on the Haskell wiki. So arrays have been around for a long time. So since Haskell 98. So yeah, it's been around. It's a big deal. You can't yeah, it's. I'm probably going to be using mutable IO arrays. It's pretty straightforward to use. You just do create a new array and you're good to go. And then there's, oh sorry, I'm going to be using the mutable arrays inside of the st monad. So you use run st. So you do run st and then chain these operations together, and you can create a new array and like modify stuff inside. That's, I don't think, yeah, that's pretty much it. That's the only new bit. I do have one more thing to show you. So I was asking earlier on the channel, and someone actually came up with a way to move those elements with respect to each other. It's efficient. I know this works. This 4-liner function is all it takes. If you're doing it purely functionally, then this is all it would take. So yeah, yeah. So I'm work for myself by using arrays, but I think it'll be worth it in the long run. Oh, another reason for wanting to use arrays is because the JavaScript source uses it. So if I go to github.com/vram4/ okay. So what's the deal with? Oh, okay. So it's back. So for a while there was a fork by this guy called vram4, and he was developing for like a solid month. I was busy, but I was still monitoring the progress, and he added a whole bunch of stuff to it, like at least 100 commits, at least maybe even 200. He was like committing like 2 or 3 times a day for a month. So yeah. So everything's pretty much the same. I don't see anything different. Yes, this is where the update move engine function is. So what that does is, so since Node.js is single threaded, they have this idea. So there's a main loop that runs every, I don't know, 10 or some arbitrary number of milliseconds, and then it just updates the move engine on that tick. So sleep for a certain number of milliseconds, and then update this, then call this tick, and then this will call update move engine. Okay. Update move. Okay, that's where it is. Yeah, so this is the bulk of it. I just want something working. I'm not going to deal with this. But yeah, this is what it does. So what I'm going to be doing is, so I already attempted to write this update move engine function, which is basically just calc move. I'll go into calc move, player packet, I think. No, that's not it. Entity, player cell, and wait, no, it's calc move. Okay. Right, so it takes a x and y to, which I'm assuming is sure what that is actually. Oh, I guess it's the position position. Okay. So yeah, pretty much it. It's the position. So let's try. So let's create a update. Wait, I think I started writing this already. I'm not sure if undo tree can, oh, there it is, move cells, that's what it was called. So it's going to take an array of int, so array, it has an int and a cell, so two, I forget what they're called, generics? Oh, well, it's third, yeah, so it takes two types. So the first is integer, which is the dimensions of the array. So yeah, so it's hard, but like it doesn't make a difference to me. And this is the important part. An array is a type associated with it, so you can have, so in Scala it would look like array cell, or in Java it would look like cell. JavaScript is dynamically typed, so I'm not sure if there's like a notation for it. Yeah, that's pretty much it. It would look like an array of cells. Alright, I forgot why. Another reason why arrays are better in this situation than lists is because arrays, when you're huge, so here's how an array is. It's a big block of space that's allocated. So when like the runtime basically just generates this block of space and says this is this cell's thing. This is an array. Okay, so what it does is, so let's say each cell is, I don't know, 32 bytes or something. Okay, so how do you get to a second thing? So what you do is just, so you know where the array starts, and if you want to get to the second element, is just skip 32 bytes, and then cell something is. This is a cell. That's how it can access. With a list, what happens is you have you basically have like a bunch of nodes in a list that contains a value and then a pointer to the next one, and that pointer points to the next value. Okay. So that next value to the next node. The problem with this is that you can't randomly access. So let's say I want to know the second element in this list. So I apologize for using this notation. I realize it looks like a type signature, but it's not. So let's say there's 3 elements, and I want to get the second element. What I would do is, I know where the start is, so I know that the list starts here, and if I wanted to just skip to the last element, what I'd have to do is take this pointer. This pointer points to this thing, this second node, and then I'd have to look at the pointer of this, and then it would take me here. You see, I have to look through every single, the one before it, I have to find the one previous to it to find the subsequent one. It's just, I'm just trying to explain how random access works. Right, so it's going to be an array. Okay, so it's going to be t array $sign. So I've already got the list of cells here. Okay. So I don't need to generate. Let's look at this calc move. All right, yeah. One more thing I need to mention. I'm not sure if so like what I did was I've defined all of these things, and I'm hoping that Haskell's will kind of like make it less inefficient, like in terms of memory. It's not going to evaluate these. It's going to allocate the space for it to store the angle, but it's not actually going to evaluate it until something. So where's the first call of an angle? Okay, so if it got through all of this, if it went through lines of code, and then it got to angle, then it'll. Oh, that's a different angle. Sorry. Okay, let's just. So basically, are there no if statements in here? Oh, yeah. Okay. So I'm defining border left, border right, border top, border bottom. So I'm already defining these. I don't have to put magic values. So what happens is it checks, it makes this check, and none of these got evaluated. There's space allocated for these three things, but there's no actual assignment. So at this point, border right is empty. There's we saved a little. We didn't do anything for that. But if this thing did fail, then it would evaluate this border right, and then it would compare it. It's really, it seems minor, and it's inefficient for like the small cases. But if you something that's like some sort of IO bound calculation, or something that's slow in general, it's going to just evaluate it only if you need it. It's like having a function in other languages. It's like having it has something similar called a lazy val, and this is, or it's yeah, that's what every single binding in Haskell is. All right, so let's get to it. I'm going to create this array. So I don't need to create this array. What I need to do is create this initial for loop. So I'm just going to skip ahead to this part. There's a for loop, and it takes out the cell at the ith position. How does that work? So there's this function called for m underscore. Let's look at the type signature for it and the documentation. For m underscore. It's in data.foldable. No, it's in control.monad. Huh. Is it? Okay, so I think it is in data. I could be wrong though. Yeah. I don't have control.monad imported. For m underscore. Okay, so let's just look at map instead. Maps each element of a structure to a monadic action. Evaluate these actions from left to right, or the results. So the important part for me is that there's nothing returned. That's what a for loop does, and this is how you do for loops in Haskell. You give it a function that performs that action on every single element of that list. case. So let's look at this. So, sorry. Sorry, caps lock was on. So in this case, what's happening? It takes a list of length cells, right? So it's still assuming that, we're still assuming that cells is a list. Hold on a sec, let me just double check. I'm just making sure that array a length thing. Come on. Data.array, okay. Okay, so okay, I should probably do this first. So I'm going to explain what this is. There's a better way to do this, but yeah, I'm going to explain what this does first. So it takes a list of 0. This dot creates a list of from 0 to the length of the cell. So if I open up my term, in a little bit, go into GHCI. Okay, if I do 0.10, produce for me a list of integers or numbers rather, from 0 all the way to 10. What I can do is I can also do something like for this. I think it's like 1.10. So I'm creating a new list again. Okay, and then I'm going to modify this list. This is called a list comprehension. Yeah, Python has something similar. A bunch of other languages. I think Python's the main one that has it. So yeah, you can do all sorts of operations. You can convert it into strings. That kind of thing. You just, yeah. So what I did was I only did this part, this range part, for this. So it gave me a list of numbers, and then it just looped over every single number, and then monadic action here. This block. What they're recommending, what I'm supposed to be doing when I have just an array is I'm supposed to do 4m. So I could do. I should probably pull this out. Ix's let Ix's equal something. So indices gives you a list of the indices in ascending order. That's what we want. Okay, the list of indices is going to be indices cells. Okay, so now I pass it. Now I give it the indices, x's, and I give it an action to perform. So this is going to be the I, and it's going to do its. Now, what does it need to do? I guess I could copy this almost completely. This whole let statement here. Wow, this entire thing. Yeah, I'm good with copying all of it. Well, why am I doing this? I could just do it like that. Just get rid of this entire block here. There. I think I've got to go, but I think this gives me a yeah. I need to update this part here as well. I need to replace this list range with IXs. And I need to update this later, but this pretty much serves the intended purpose. All right, see ya.